Bismillahirrahmanirrahim. Assalamu alaikum. I am Mrs. Nadia Roo from Army Burnhall Girls College, Ahmedabad, and today we are starting with third lecture of chapter number 16, that is hydrocarbons. In today's lecture, we are going to discuss nomenclature of alkenes and alkynes in detail, that is the nomenclature of unsaturated hydrocarbons. By the end of this lecture, you should be able to learn some rules of nomenclature of unsaturated hydrocarbons, and you should be able to name various alkenes and alkynes, that is unsaturated hydrocarbons, in a precise manner. What is an alkene? You have heard about it already. Alkenes are those hydrocarbons which have got one or more carbon-carbon double bond in the chain. Having one, these are also called as olefins because they make oily substances when reacted with chlorine and halogens, etc. Their general formula is CnH2n. In comparison to alkanes, which had formula of CnH2n plus 2, these ones are having 2 hydrogens less than that of alkanes. That's why their formula is CnH2n. You can see an alkene that is being shown to you over here. The name of the simplest alkene is ethylene, or proper name is ethene. Ethylene is the common name of this compound. They have got one sigma bond and one pi bond in their structure. In these two bonds that are present between two carbon atoms, one of the bond is sigma bond and another bond is the pi bond. You can see the orbital picture of the simplest ethene molecule as well. Now coming to another class of unsaturated hydrocarbons, which is called alkyne. Alkyne are those compounds which have got one or more than one triple bond in the continuous chain. These are also called as acetylenes. Acetylenes is their common name, and they have got general formula of CnH2n-2. They have got 2 hydrogens further less than that of alkenes. This acetylene, you can see it has got one sigma bond which is holding 2 carbon atoms, and it has got 2 pi bonds in its structure. These pi bonds are above and below the plane of molecule. This is the simplest alkene, that is alkyne, which is being shown to you. Its name is ethine, or the common name is acetylene. These triple bonds have got one sigma bonds and they have got 2 pi bonds in them. Orbital picture is being shown to you people over here. You can see 2 carbon atoms are jointed by sp hybridization, and this sp-sp hybrid orbitals that are shown in the pink color, they are bonded by a sigma bond, and p orbitals that are shown over here with the green color and blue color, they are bonded with each other, making 2 pi bonds above and below the line joining 2 of the carbon atoms. You are familiar with the structure already as well. After understanding the structures of alkenes and alkynes, let's move on towards nomenclature of alkenes and alkynes. Some common rules are being told to you people over here. The first one is the most important one. You have to select the longest chain which should have both of the double or triple bond if it is present in the molecule. You can see in this structure, this is the chain which is having less carbon atoms as compared to this chain. This is having more carbon atoms, but as this chain is not holding a unsaturated bond, so that's why we are not going to choose it. We are going to choose the chain which should have double or triple bond in it. So this molecule will be named as butene instead of pentane. It should be pentane in this way, but it is not a pentane because this cannot be considered as a substituent. This is a functional group. This is going to give some specific properties to this compound, so it must be included in the longest chain. Then you can see the other structure as well. In this structure, you can see the shorter chain is having a double bond which is holding only 4 carbons. Instead of that, if we start counting carbon atoms from this side, it will be having 1, 2, 3, 4 and 5 carbon atoms, but it is not holding a double bond, so we are not going to choose it. We have chosen this chain which was having a double bond in it, and this side alkyl group will be acting as a substituent. It will not be included in the longest continuous chain. Same rule is going to exist for triple bonded compounds as well, the compounds which are having triple bond in them. For example, examples are being shown to you. In this example, you can see triple bond is again, the longer chain is not holding a triple bond, so we are not going to choose it. We are going to choose the chain which should hold a triple bond in it. So this chain will be chosen and it would be named as butane instead of this one. This can be named as pentane otherwise, but it is not holding a triple bond, so we are not going to choose this one. So in that case, you would see this compound, the first compound that has been shown over here, this will be wrong, and the second compound will be the correct one. This is the longest chain that is holding a triple bond in it. This was the first rule of nomenclature for unsaturated hydrocarbons. Moving on towards second rule. The second one is you have to number the chain from the end nearest to the multiple bond. Whether it is a double bond or triple bond, you should number the chain in a way that the double bond should be getting the lowest number. As you can see in this example, if I start numbering from this side, this carbon atom you can see is holding double bond. This chain is holding double bond at position number 2, but this chain, if we start numbering from the other side, we would see this will be third carbon that is holding a double bond, so this numbering will be incorrect. We have to give lowest number to the multiple bond, whether it is a double bond or a triple bond. You can see the example. In this example, this is 4 carbon compound holding a double bond at position number 1, so it would be named as 1-butene. But this is the compound, this is holding double bond at position number 2. We number it either from this side or from the other side. In both of the cases, this carbon will be, this double bond will always be at position number 2. So 1-butene and 2-butene, these two are the correct names of these two compounds. We have to replace, in case of alkanes, whatsoever is the name of alkane, like propane, butane, heptane, hexane, you have to replace the word ane by ene when it is holding a double bond. So any alkane would become alkene, butane would become butene, you have seen pentane would become pentene if it is holding a double bond in its structure. Same rule will be applied to triple bonded compounds. For example, you can see in this compound, it was holding triple bond at position number 1, and this was included in the chain, so it is the correct numbering. But if it is not holding a triple bond in the chain, it will be incorrect in that case. If I number this compound from this side, it will be the correct numbering because triple bond is holding the lowest position of the carbon atom or lowest numbering. If I start numbering from the other side, this will be third carbon which is holding a triple bond, so this will be the incorrect numbering in that case. For example, some examples are being shown to you. This is a compound having triple bond at position number 1, and this is a compound having triple bond at position number 2. So they can be named as 1-butene and 2-butene as well. Again, when we are going to name alkynes, we are going to replace ane of the alkane by -fine. So any butane would become butene, hexane would become hexine, heptane would become heptine, and so on. The next rule is, if you are having multiple bonds in between the chain and it is equidistant from both of the ends of the chain, means it is at equal distance from both of the sides. In that case, which numbering you are going to choose? You can see this compound. If we see the continuous chain holding a double bond, we can start numbering either from this side. Even in this case, it is going to give double bond number 2, and if I start numbering from this side, even then in that case number 2 will be given to the carbon atom holding double bond. But now which numbering you have to choose? We have to see the substituent. Where is substituent present? We will have to prefer the numbering which is giving lowest number to the double bond as well as the substituent. So in this case, first name is correct one and the second name is not correct, because in this case substituent is getting number 3, so which will be incorrect. In first case, both of them are getting lower numbers. In the next rule, you will have to see what is the position of multiple bond. You will have to, because multiple bond is usually between two carbon atoms, so both of the carbons are getting numbers, so you will have to name the compound according to the lower number of the carbon atom. Lower numbered carbon atom will be used in the naming of that compound. For example, if we see this example, it is carbon number 1 and 2, both of them are holding a double bond, so we are going to name it as 1-butene. You are going to tell the position of double bond which is at position number 1 right now. You cannot call it 2-butene because double bond is starting from carbon number 1 and ending it at carbon number 2, so we have to name it according to the lower numbered carbon atom of that compound. If there is more than one double or triple bond present in the chain, then what you have to do, which numbering you will have to choose? You will have to number the chain from the end which is holding the first multiple bond, right? For example, you can see these examples. In these examples, there are 2 double bonds present. We can start numbering either from this side or you can start numbering from that side, but this will be incorrect. We have to start numbering from whichever side which is getting the lower number, which is giving lower number to the first multiple bond, right? So in this case, the first numbering will be correct one and second will be incorrect one. You can also apply the rule of sum of locates as well on these compounds. If you do the sum of these carbon atoms, you will see the sum of these two will be 1 plus 3. Double bond is at position 1 and 3, so it will give sum of 4. In this case, double bond is present at position 2 and 4, so the sum of 2 and 4 will be 6. So this numbering cannot be chosen in that case. For example, next rule is if you are there is 2 double bonds or 2 triple bonds present, then how you are going to name it? 2 double bonds will be named as diene, 3 double bonds will be named as triene, and 4 double bonds will be named as tetraene. In case of this compound, you will have to name it as butadiene. Butadiene means, buta means 4 carbon atoms having 2 double bond, di for 2, ene for 2 double bonds, and you have to, before that, before naming, you will have to indicate the position of these 2 double bonds, where they are located. They are located at position number 1 and position number 3, so they will be written in this way: 1, then you will have to put comma between 2 of the numbers, that is 1 and 3, then put a hyphen, and then butadiene, the name of compound, will be written. Similarly, in case of alkynes, diene, triene and tetraene will be utilized for 2, 3 and 4 triple bonds. For example, the example being shown to you is 2,4-hexadiene. We can see if we number it from this side or from the other side. Both of the cases, triple bond is present at position number 2 and position number 4. So it is a hexadiene. Hexa for 6 carbon, di for 2 and yne for 2 triple bonds. So the position of triple bonds will be shown by 2 and 4. Whenever you are facing any doubt, you will have to apply the rule of sum of substituents. Means, if you are having doubt in which numbering should be chosen, either I'm numbering it from this side, this is the correct one, or if I'm numbering it from the other side, that is the correct one. In that case, apply the rule of sum of substituents or rule of sum of locates. For example, in this example, we can see there is a substituent, there are two double bonds as well. So which numbering should be chosen? If I start numbering from this side, it will get 1, 2, 3 and 4. Position 1 and 3 are holding a double bond, and at position 2 there is a substituent present. So the name of compound will be 2-methyl-1,3-butadiene. If I number it from the otherwise end, in that case double bonds will again get the same numbers 1 and 3, but substituent will get number 3 in that case. So sum of all of them, like 2 plus 1 plus 3 will give you 6, and here sum of all of the substituents, that is 3 plus 1 plus 3, that will give you 7. So this is giving the highest sum of substituents, so this name will be incorrect. We will have to choose this name. The common name of this compound is isoprene as well. Similar example is being shown. In this example, there is a substituent at position 2 and there is a double bond present at position 2 as well. If I number it from the otherwise end, in that case there is double bond at position 2, but then in that case 1, 2 and 3, this substituent will be present at position number 3. So if I name it as 2-methyl-2-butene, or if I name it as 3-methyl-2-butene, which one will be correct? I'll have to apply the rule of sum of substituent. When we apply rule of sum of substituent, 2 plus 2 gives you 4, and here 3 plus 2 gives you 5. So this will be the incorrect name. Instead, this will be the correct name. Some common names are also being shown to you people. Some common names of some of the alkyl groups are being shown to you people. These are not utilized in IUPAC system, but these are utilized otherwise as a common names or trivial names. This group, that is ethene, when one hydrogen is removed and it is utilized as an attachment, then this is sometimes called vinyl group as well. It is also called, from ethene we are removing E and we are replacing it by YL, so it would become ethenyl. Ethenyl nahi hai, it is ethenyl. Similarly, if it is attached with something else, like here it is attached with chloride group, it would be called vinyl chloride. This is a vinyl group and this is a chloride group, so it would be called vinyl chloride, or chloroethene is also the name of same compound. This group, when propane is holding a double bond, it becomes propene, and when from the last carbon atom there is attachment with something else, this group is called allyl group. It is also called as 2-propenyl. When it is attached with something, we have to start numbering from this side. So 1 and 2. At position 2, there will be a double bond present. This group is called allyl group when it is utilized as a substituent. For example, if it is attached with the chloride, it would be called allyl chloride as well. Its proper IUPAC name will be 3-chloropropene. For us, IUPAC names are more important than the trivial names. Now moving on towards nomenclature of some cycloalkenes, some cyclic compounds, some cyclic unsaturated hydrocarbons. When cyclic unsaturated hydrocarbons are present, in that case we have to number the ring with the carbon that is holding a multiple bond. For example, this is a cyclopentene having a double bond in the ring structure. When you have to number it, this one can be called cyclopentene. We don't need to mention any position of double bond. It can be present anywhere. It can be present here, 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 or anywhere. It would always be called a cyclopentene. One cyclopentene, or simply one need not to be mentioned, so it can be cyclopentene. In this case, we always have to start numbering from the multiple bond, because multiple bond is over here, so we will start numbering from 1, 2, 3, 4 and 5. So this compound would be called 3-methyl cyclopentane. We cannot start numbering from this side 1, 2, 3, 4 and 5. In that case, you can check it by using the rule of sum of substituents as well. That will give you the bigger sum. So we are not going to choose this side. We are going to choose this clockwise numbering. Similarly, when there are two double bonds present, in that case it would be called cyclohexadiene. It can be shown in this example where there are two double bonds which are present on this compound. We can start numbering from any double bond. We can start it from here or we can start it from here as well. So it will be 1, 2, 3, 4, 5 and 6. So double bond is present at position number 1 and position number 4. So this compound is called 1,4-cyclohexadiene. Similarly, we can have 1,3-cyclohexadiene as well. There is a double bond present at position number 1 and at position number 3. If you number it in the clockwise direction, in that case you will see that it will give you the larger sum of substituents. So we are not going to utilize that numbering. After understanding the cyclic unsaturated hydrocarbons, let's move on towards the rule for naming molecules that are having both double and triple bond in the continuous chain. In that case, you will have to choose, if both of them are present, double and triple bond, whichsoever is the bond present which is closest to the end of the chain, that will determine the direction of numbering. Whichsoever bond, whether it is a double bond or triple bond, it is present at the end of the chain, that numbering will start from that side. For example, in this example, there is a double bond as well as a triple bond. We can see triple bond is present at the very end of the chain, so we will start numbering from this side. We cannot start numbering from this side. So the name of the compound will be pent-3-ene-1-wine. Pent-3-ene-1-wine means at position number, this is a pentane having 5 carbon atoms. At position number 3, there is present a double bond, that is ene. Then further we drop E, last E of ene, and we write 1-wine as well. 1-wine means at position number 1, there is a triple bond present as well. In case numbering is, in case we are having both of the double and triple bond present in the chain and both of them are getting the same number from either sides, in that case we are going to give lowest number to the double bond. Double bond will always get preference over triple bond in numbering if both of them are present at equal position. So in this case, the numbering will start from the double bond and name of the compound will be pent-1-ene-4-wine. Pent stands for 5 carbons. 1-ene means there is double bond at position number 1. We are dropping E of the ene and we are writing 4-wine, indicating the position of triple bond at position number 4. This can also be written as in this way: 1-pentene, dropping E of the pentene and instead of that putting 4-wine in that place. Similarly, another compound is being shown. It is hexa compound having 6 carbon atoms, and at position number 1 and 3 there are 2 double bonds. We are starting numbering from this point where both of the double bonds are getting the lowest number and triple bond is getting the highest number among all these 3. So the name of compound is hexa 1,3-diene, again dropping E of the parent name and in place of that putting 5-wine. This can also be written as 1,3-hexadiene-5-wine. To remember, ene will always precede wine in the name of the compound because alphabetically it comes first, E comes first as compared to Y. So that's why the parent name will always be upon double bond having ene, and then in the end the last one will be wine, that will be ending the compound. Now, how you have to write the name of a compound that is holding a double and a triple bond. If both in double and triple bonds are present, then their locations or their locants are usually written before their respective suffixes. Suffixes are ene or wine. So we have to remove the E from the ene and then we have to write the name. The name will be written in this way. For example, this is the example where we are having a triple bond and a double bond in the compound. Numbering is starting from the end, which is having the triple bond. In this case, the name of compound is a pent-3-ene, it is all double bond I told you is always given preference over the triple bond of when we are naming a compound. So when name will be given, it will be upon double bond, that is pentene. Which pentene? It is a 3-pentene. At position 3 there is a double bond. So pent stands for 5 carbons, 3 for the position of ene stands for double bond. This E will be dropped and we are going to add one wine. At position 1 there is a triple bond, so the name of the compound would become pent-3-ene 1-wine. So this is how you are going to write the name of the compound. So these were all the rules regarding nomenclature of hydrocarbons, unsaturated hydrocarbons. I hope you are going to practice them at your homes, practice all of the examples, and let me know if you are facing any problem anywhere through your WhatsApp group. Now moving on towards questions from the previous lecture. There were some questions given to you from the previous lecture and I asked you to do it at your homes. The first question was, give IUPAC names to the following compounds. There were various parts given to you. So let's check your answers now. You will tally your answers with the answers that I am going to tell you now. The first one was this compound. The name of first compound is 2-methyl-pentane. It is a pentane. Longest chain is having 5 carbons. At position 2 there is a substituent present. The name of second compound, do remember whenever CH3 comes within the chain and bracket is written, parenthesis brackets are present around CH3, that means it is not inside the chain, it is present as a substituent above and below the previous carbon atom. So these are two substituents present with this carbon, so the name of the compound will be 2,2-dimethyl-butane. The next two were given to you. Again, when CH3 is present, it is present in the form of a branching. So with this carbon CH3 and here CH3 group will be attached. With this carbon again there will be two CH3 groups attached. Rest CH2, CH2, CH3 are included in the longest chain. So the name of compound is 2,3,3-trimethyl-hexane. Similarly, this is a simple compound. You can see you will have to start numbering 1, 2, 3, 4, 5, 6, 7. If you include this one in the numbering, even then that would be fine. Even then it will be heptane. The position at position number 2 there is a methyl group, and at position number 5 there is a ethyl group attached. So it will be 5-ethyl 2-methyl heptane in that case. The next few parts were, now you have to choose the longest chain. In this part, the longest chain seems to be this one. 1, 2, 3, 4, 5, 6, 7 and 8 carbon atom. Otherwise it is having 7 carbon atom. So we are going to choose this chain and we are going to number it from this side as well. So the name of compound is 3,3,5-triethyl-octane. This will be 3,3,5-trimethyl-octane. At position number you can see 3. There are 2 methyl groups present, and at position 5 there is another methyl group present. So the name of compound is 3,3,5-trimethyl-octane. Next part is this one. Again, these CH3 will not be included in the longest chain. They are acting as a substituent. The last one will be included in the longest chain because it is in continuation with this carbon atom. So the name of compound will be 2,2,3,3-tetramethyl-hexane. 2,2,3,3-tetramethyl-hexane. The last part, again you have to see the longest chain. This one seems to be the longest one. 1, 2, 3, 4, 5, 6, 7 and 8 carbon atom. And when you are going to number it from this side, it will be 1, 2, 3. At position 3 there is a methyl group. 4 and 5 at position 5 there is a methyl group. At position 5 there is ethyl group as well. So name will be 5-ethyl 3,5-dimethyl-octane. Another question that was given to you was related to cycloalkenes, IUPAC nomenclature of cycloalkenes. Give IUPAC names to the following cycloalkenes. I hope you remember the question. Now let's find out their answers. The answer of first part. The answer of first part is 1,4-dimethyl cyclohexane. We will start numbering from this side or from that side. Both of the cases will be correct. So starting it from this side, 1, 2, 3 and 4. It will be 1,4-dimethyl cyclohexane. The next question is this one. We have to name it from the side where there is alphabetically preferred, we can say alkyl group would be present. As I can see, this is a methyl group and this is a propyl group. So this is alphabetically preferred, so we are going to give it number 1, 1, 2 and 3. So it will be 1-methyl 3-propyl cyclopentane. Similarly, in this compound, now you will have to see there are 4 carbons in the cyclochain and otherwise 1, 2, 3, 4 and 5 carbons in the normal chain. So we are going to choose this one as the parent chain and this will be treated as a substituent. So the name of compound will be 3-cyclobutyl because it is acting as a substituent. So it would be called cyclobutyl, which is present at attached at position number 3, that is 1, 2 and 3 of a pentane. So it will be 3-cyclobutyl pentane. The next part is this one. When you count number of carbon atoms, there are 10 carbon atoms in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the name of the compound? It is a cyclodecane. At position number 1 will be given to bromo group because alphabetically it will be preferred over ethyl. So we are going to start numbering from this side. So it will be getting position number 1, 2, 3 and 4. So 1 bromo 4 ethyl cyclodecane. The next part is this one where we can see CH is present in the center and as 2 branchings there are 2 CH3 group or 2 methyl groups which are present. So it would become isopropyl. One attachment is isopropyl, another attachment is methyl and the major compound is cyclohexane. So the name of compound will be, we will start numbering from this side, 1, 2, 3, 4, 5 and 6. So it will be 1 isopropyl 2-methyl cyclohexane. The next compound, again we have got this carbon is present in the center which is holding 3 methyl groups as branching, so it would become isobutyl. This is methyl and this is bromo group and this is a cycloheptane with us. So what will be the name of compound? We are going to start numbering again alphabetically. We are going to see iso as I will be iso is included in IUPAC numbering scheme. So iso alphabetically will be preferred. So we are going to number it from this side, 1, 2, 3, 4, 5, 6 and 7. So it will be 4 bromo because bromine comes first. It will be 4 bromo, 1 isobutyl, 2 methyl and it is a cycloheptane. This will be called a cycloheptane. Now you would be a little bit confused why this bromo is not given number 1 because it alphabetically comes first. Why? Because if we give it number 1, in that case this methyl group will get number 3 and this will be getting number 4. So you can apply the rule of sum of locands that will give you the more larger sum as compared to this numbering scheme that I have shown you. That's why we are following this one. This one is giving us lowest sum of locands. That's why we are choosing this kind of numbering scheme. Now there are some of the questions that are given to you now for practice at your homes regarding nomenclature of unsaturated hydrocarbons. This is activity which is given in your books. It contains 3 parts. Part number 1 is name following olefins using IUPAC nomenclature system. You will have to name all of them, keeping in your mind all of the rules that you have studied today. Then question number 2 is name the compounds A and B by IUPAC. You have to attempt these two parts according to IUPAC nomenclature. Compound C and D by their trivial and common names. These two should be the trivial or the common names must be utilized. Go through the lecture once again, you will get to know. And E by its derived name. How? You are going to derive a name from the trivial name. So you are going to name it in that case. Draw structure formulas of the following compounds and discuss geometric isomerism in these cases. 1, 3, this is not butadienes, there is some typing mistake. This is butadiene, this is 1, 2 pentadiene, 2, 4 hexadiene, this is 2 methyl 1, 3 butadiene, 3 methyl 1, 3 pentadiene. We have discussed isomers already as well in the previous lecture. So draw all of the isomers of these compounds and let me know if you can do it or not. There is another activity which is given in your books that is also being given to you as a practice, and you will do it at your homes and you will be getting answers in the next lecture, inshallah. This is another activity. Give IUPAC names to the following compounds. There are almost 5 parts and you have to name it according to IUPAC nomenclature system. Do it and then let me know if you are facing any trouble anywhere. Okay, thank you very much, girls. That's all for today. Thank you very much. Have a good day.